In this lecture, we'll talk about these two examples. The first one is convert the rectangular equation to a polar equation. That's one. The second one is different, is we are given a polar equation. We want to get a rectangular equation. Okay. So this one is based on the knowledge we have learned before, is the one right here. You always want to do is x equals r cosine theta and y is r sine theta. Or if you remember, you may write in this way. Okay, but you know, we want to use this pair this time. Okay, x equals r cosine, not sine. That's the thing we want to remember. Okay, now down here is that everyone knows this is a linear equation, but you know, we like to convert this one to a polar equation to see how well it looks like or how bad it looks like. Okay, we know x is r cosine theta and y is r sine theta. Okay, now you plug in x and y, so 3 times r cosine theta plus y, plug in this one, so r sine theta equals 5. Okay, you then can pull r out, so r is out, so you have a 3 cosine theta plus sine theta equals 5. Now, both sides divided by a big quantity right down here, that will be 3 cosine theta plus sine theta. Right hand side is the same, 3 cosine theta plus sine theta. Okay, so then we get will be r equals 5 divided by 3 cosine theta plus sine theta. So this linear function here looks so easy, here it looks very complicated. So that's the disadvantage for the polar equation, for the linear one, linear function or linear equation. Later on you will see when we introduced these polar equations, we can actually do very good thing. This is a bad thing. If I give you this equation, you may not have any ideas how does the picture look like. Okay, so for the linear function or equation, this one doesn't look like a good example. But you know, once you look at this kind of things more, you may get used to it. Alright, anyway, you will see a good example later. Now, here is to convert the polar equation to a rectangular equation. Okay, we have no idea how does this graph look like, but once we convert to the rectangular equation, you then have an idea how does the picture look like. Okay, yeah, Now, we know R is 8 times cosecant, but cosecant is what? Is 1 over sine theta. Okay, 1 over sine theta is cosecant, not 1 over cosine theta. Now, if both sides multiplied by sine theta, what we get is what? Right hand side, you cancel sine theta. So right hand side is 8. You may write 8. Left hand side is R times sine theta. Remember, R times sine theta is Y. So basically what you get is what? Y equals 8. Y equals 8. Everyone knows, yeah, that's a line. Y is 8 means x can be any value. So basically, you can simply draw the picture. Y is 8. Let's say here is 2, 4, 6, and then here will be 8. Y is a constant. X can be anything. So it's a horizontal line, okay? Not vertical. Yeah, be careful. Alright. These two examples basically tells us that right now looks like rectangular equation is much better than the polar equation. Later on you will see the polar equation sometimes is much better than the rectangular equation. So it depends on the situation. Sometimes we use polar equation, sometimes we use rectangular equation. Okay, please review this lecture. I'll see you next time.